Okay, hello class. Today we are going to look at lists. And actually we're going to see that today lists are actually very similar in concept to strings. But there is one big thing we're going to be talking about today which makes a list different than strings. So let's first off recall that strings themselves are an ordered collection of characters. And so, we saw that we can create a string, and we use these quotation marks as a way of indicating this is a string, and it's an ordered collection of characters. Now, lists are also ordered collections, but instead of holding only characters, a list can hold any sort of Python object, any type. They can be strings, they can be integers, floating points, booleans, turtles, whatever. And everything in Python actually is an object. A list is an object, so a list can be held as an object inside of another list. We see here that 5, an integer, a string, a floating point, a boolean, and even another list can be held within the list itself. Now, the syntax in Python to define a list is by having these kind of rectangular brackets on each side, in a similar way that these quotation marks indicated the list. We have these brackets on either side which indicate we have a list, and then we have all the different objects inside the list separated by commas. So over here we had 5 characters in the string, and over here we have 1, 2, 3, 4, 5 objects inside of the list. Now, if we want to have an empty list, we can have an empty list. It's just bracket, bracket, just like we had an empty string. By having back-to-back quotes, we could have an empty list as well. Now, spaces don't matter in terms of a list, so we could actually have an empty list like this, where all these invisible spaces don't matter at all. They are meaningless, and so this is also an empty list, just like this is an empty list. Now, just like we can assign a variable name to a string, we can also assign a variable name to a list as well. Now, once we have a string, we were able to do something like this, which would then specify a particular character within the string. And in this case, S1 means we're referring to the letter E. Now, we can also do the same thing with lists as well. We can access specific elements within a list in the very same way with the very same syntax. So if I have a list here and it has 1, 2, 3, 4, 5, 6 elements, my list 0 references the first object here, A. My list -1 references the last item in the list, which is actually the word last in this particular case. And if I actually try to access an object that is at a position that is not, within this list, like my list 100, I get an index error. And all of this is just the exact same thing that we would have for strings. Okay, so in some sense, no difference. Remember, with strings, I could also access a substring. So, if I had S equals hello, I could say S1, starting at character 1, up to but not including character 3. This would be referencing the string EL. The E at position 1, up to but not including this L at position 3, so it's just the E and the L. Same thing with lists. We use this slicing kind of notation here, where we have the A:B, and we can access a sublist now. Now notice that this will always give you another list in return. So my list 0:1 says start from the first item up to but not including the second item and put it inside of a list. So that's why we have A within a list. Now I do want to contrast that with my list 0, which in this case is just the letter A. Notice how these are different. Notice the difference. In this case over here, we're accessing a single element, a single object in the list. And what gets retrieved by this is not a list. Whereas in the other case, we are actually accessing a sublist, 0 up to but not including 1. So what we see here in this case is a list of a single element. Okay, so my list 1 up to 4 will include the elements 1, 2, and 3. My list 7 to 10, there is no element 7 in this list. But remember, we always get a list, and so in this case it's the empty list. So I want to highlight this one, and I want to say that there's no index error. You know, if I said my list 7, and I'm not using, you know, the slicing kind of notation here, I would get an index error for my list 7 because there is no item at position 7. But if I'm using the slicing notation, I always get a list. I do not get an index error. So kind of a corollary to this important point here is that I never get an index error. Because I always get a list, I never get an index error. And this is actually the same thing it was with strings. So in some ways, I'm just reviewing how it worked with strings as well. Okay, so my list 2 means everything from the very beginning, from 0 up to but not including 2. And then we have 4 : meaning everything from element 4 all the way to the end. Now we also have the length function, which works the same exact way that the string function, that it worked with strings. It works with lists as well. We also have the in and the not in keywords in Python, which says, is this item inside a string? Or in this case, is this item inside of a list? And so if I said something like this, is A in my list B cat D, this would be false. A is not one of these 3 objects. A is not B, A is not cat, A is not D, and so it's false. Now don't get confused here. A is a letter inside cat, but that's not what this in operator is doing. It's just saying whether this object is one of the objects inside of this list, and it is not. Okay, so I'm going to just pause for a little bit here. You could pause your video and you can do these 3 problems. I'll count down here, 3, 2, 1. Okay, so the length of my list, is 1, 2, 3, 4, 5, 6. Is cat in my list? Yes, it is right here. So that's going to be the true Boolean. And then I want the sublist, which starts at position 2, right here, but does not include position 2. So what is that? That's actually the empty list. So this last one's a little tricky. I didn't show that earlier. All right. Now again, similar to strings, we have the plus operator. Similar to strings, we have the multiplication operator, which is replication or repetition. And it works the same way as one might expect. So I can add or concatenate two lists together. So A, B, C, 1, 2, 3 will be my resultant list. I could add a list that's referenced by a variable to an explicit list. And I could replicate or repeat a list multiple times. So it's like saying 1, 2, 3 plus 1, 2, 3 plus 1, 2, 3. That gets me one big list containing all 9 elements. Now notice that in all these cases, a brand new list is created whenever concatenating or repeating or replicating. These original lists remain the same. They do not change. Now, so far, all of this in some ways has been a little bit of a repeat or a review of how strings worked. Now, we're going to kind of see a major difference between strings and lists. Strings, if you can recall, were not mutable. You cannot change a string object. So if I have a string, and we have this object here that has the word example, and I notice I spelled the word wrong and I want to fix it, and if I tried to say, okay, change the second or the letter at position 2 to an A, I cannot do that in Python. It will not allow me to change this object once it's been created. Now in Python, lists are mutable. I'm able to change an element if I want to. I could delete an element. I could add an element to a list. So if I had a list and say it's 1, 2, 3, it's completely legal to change this to some other value. It's completely legal to delete one of the items in the list. It's completely legal to insert or add additional elements inside of the list. Whereas with this string, cannot change it. Once it's made, no changes allowed. Okay, so this is a pretty fundamental difference between lists and arrays that I want to highlight, and I want you to make sure you know. Okay, so let's talk about how I would change a single element in a list. I do that with indexing. So in this case here, I have a misspelled word and I want to change it. So because lists are mutable, I can easily change any item in this with something else. So what I'm saying is take this list and change the item at position 2 with this new item right here. And so in this case, what will happen is fish will get replaced, and when I print it out, I'll see the new item within the list. I could also do this with multiple elements. So in the next case, 2 of the elements are not correct, and so I would like to replace them. So I could replace items 0 and 1 using this slicing method right here. So the slicing method will change both of these items, and it will replace it with all of the elements inside of this list, and so then it gets all fixed up. Now, I do not need to replace it kind of one for one. So just because I have 2 elements here on the left-hand side does not mean that I need to have 2 elements on the right-hand side. It is completely legal. I could have done the following. I could have said, take the first 2 elements and exchange it with 1, 2, 3, 4. And so what would happen is I would get the following. I'd get a list 1, 2, 3, 4 with fish and horse. So again, the big idea is I can replace the left-hand sublist with a right-hand sublist or a right-hand list. And this could have no elements in it, one element, 100 elements. It doesn't matter. Whatever's on the right-hand side will replace whatever is specified on the left-hand side. Okay, so give this a try. We're going to end with this, and I'll just pause this a little bit. Count down, 3, 2, 1, and then I'll show the answers here. So in this case, I want to replace this item here, which is at position 2. I want to change it to a 10. In the next case, I want to change the 8, 5, and the 9. Let's number these. 0, 1, 2, 3, 4, 5, 6, 7. I would like to change all of these elements here. So in this case, I need to say my list elements 4 up to, but not including element 7. So 4, 5, and 6, elements 4, 5, and 6. These three objects will be replaced by 80, 50, 90. Okay, that's it. All right, we'll continue on with lists some more, but until then, I will see you. Have a good day, everybody.